This is a high-level overview of the pay-to-write database. I wanted to introduce this concept to other blockchain developers that are following my work in the space. So this P2WDB, it's an acronym for pay-to-write database. And what it solves two problems in the blockchain space. On-chain data uh, is this problem that all blockchains have with regard to scaling. Blockchains can be thought of as a censorship resistant database. That's one good way to think about a blockchain. They're really good on the censorship resistance part, but they're really bad on the database part. So you'll often hear terms of like bloat or state management. And it's one of the hardest scaling problems in the blockchain space. And the pay to write database helps this problem by moving data off chain, but still being able to access the data on chain. So it's sort of the best of both worlds, and I'll get a little bit more into that. And then there's also this problem of cross chain communication. Blockchains are basically islands. They don't communicate with one another natively, and the repercussions of this is that blockchain projects are often devolve into zero sum games where you get this tribalism and this mentality of like our coin can only succeed at the cost of these other people's coin or blockchain or coin. You can swap them out there. And so it leads to this very toxic culture within the blockchain space, and the perception of a zero sum game when it really is not a zero sum game. And so the pay to write database allows blockchains to communicate with one another, again, on chain. So these are two really big, deep problems. I'm just glossing them over on the surface, but there's actually a lot of knowledge embedded in understanding these two concepts. But this is a sort of an architectural overview diagram of what the pay to write database and how it's built. Without going into the details, as a application developer, or if you're thinking like, what is this useful for? So there's these two problems, but how do you sort of interact with it? Well, over here on the left are the different interfaces. So it's intended to be interacted with using the REST API over HTTP. Now, this is the normal Web 2.0 way of communicating with one another. So Twitter, YouTube, Facebook, all the apps that make the web, what it is today, uses the REST API. Maybe they use a slightly different interface, but they're using something like a REST API over HTTP. So you can just sort of think of Web 2.0. So this is designed with that in mind. You can communicate with the database the same way that you would communicate with any other Web 2.0 database. The second interface is one that I created called the JSON RPC over Ipfs. Now, this is a general interface that's useful in a lot of different scenarios, but it's intended to be a drop-in replacement for the REST API. It's a little slower, but it's a little more censorship resistant, and so I don't need to go too much into this, but it's basically a drop-in replacement for a REST API that makes this trade-off of being a little slower but much more censorship resistant than a REST API is. So this is good for, say, a service in America who wants to provide services to people in China or Turkey or Venezuela, where state actors might get in the way of two people peacefully conducting a trade. The JSON RPC over Ipfs is a great way to tunnel through some of those state-sponsored firewalls and acts of censorship. And then finally, there's the on-chain read and write. And so this is, again, the ultimate in censorship resistance, but it's also the slowest and least easy to use with technology that exists today. This allows any blockchain to read or write to the database directly on-chain using native methods. And so that's sort of the ultimate in censorship resistance. So you have three different ways to read and write to this database. And then here in the center is the actual pay-to-write database architecture. So down here at the bottom are the blockchain-specific local databases is what I call these. So I have one here for the Bitcoin Cash blockchain, one for the Avalanche blockchain, one for the eCash blockchain. You could go on and on and on. You could have Ethereum. I don't think BTC would work very well, but theoretically it would work. But anyways, each blockchain is going to have its own sort of local version of the pay-to-write database. And the way that the pay-to-write, the reason it's called pay-to-write is that anyone can read from the database. But in order to write to the database, you have to submit a proof of burn. And what a proof of burn is it's simply a transaction ID. If you have ever sent a cryptocurrency using any of these blockchains, you will have encountered a transaction ID. It's essentially like your receipt that your transaction happened. And so in order to write to the database, you submit the data you want to write and you submit a transaction ID. And the database will go to that blockchain and verify that you burned a specific token, a specific quantity of a specific token, and that's your ticket to be able to write to the database. So right now, what that is it's the PSF token for the Permissionless Software Foundation, which is what's sponsoring this project, and you have to burn 0.01 of those tokens. And if you burn 0.01 of those tokens in a transaction, you can submit the TXID along with the database, and the pay-to-write database will allow you to write to the database. And the other thing, important concept in this pay-to-write database, is that it's a peer-to-peer database. So it functions similarly to a blockchain where there are a lot of peers on the network, and each peer individually validates the rules of their copy of the database. But then they all collaborate to maintain a single database, in exactly the same way that a blockchain is a database. And then there's this global pay-to-write database that anytime you write to one of these local databases, that data gets pushed up to the global database. And so this becomes an aggregate database of all the data that's in the blockchain-specific databases. And in this way, this is how it becomes a cross-chain data communication medium. Because any blockchain using this on-chain interface or any of these other interfaces can read from the global database. And so you can write to it from any specific blockchain and read to it from any other blockchain. And then finally here on the right is the Filecoin backup. So this technology is based on IPFS, the Interplanetary File System, and OrbitDB is the database structure that we're using. And because those two are native to IPFS, Filecoin, which is the blockchain for backing up data, also is native to IPFS. So at any point, any person can back up the database, part of it or the whole thing, to Filecoin. And so the plan moving forward for this project is that every 3 months the databases will be backed up on Filecoin, and then once a year this global database will be sunset and a new database will be created. So probably the way this will work, that I imagine it, is like in October the next year's database will be created, and then in January 1st the previous year's database will be sunset, so there will be like a 3-month overlap. And in this way we can keep the database small, and keeping the database small makes it much easier. It improves its censorship resistance, and it makes it easier to replicate and improves decentralization. And then getting data from that sort of archival versions of the database, that will be a secondary service that people can charge for. But again, that data will be on Filecoin and IPFS, so no one necessarily needs to pay for it if they're willing to learn how to access it that way. But there will more than likely be paid services for people who need to access older data. So it's trying to achieve this best of both worlds, being able to retrieve old archival data, but keep the current database nimble and small and highly censorship resistant. And so I think I'm going to wrap this up here. I just wanted to introduce some of these high-level concepts. You can come to this README if you want more details. Everything is on GitHub under the Permissionless Software Foundation GitHub group, and this is called Ipfs, Pay to Write Database Service. And just real quick, if you want to, so this is the documentation. You can scroll down here. There's additional background information, code examples. There's a developer documentation that goes even deeper into this architecture. And then there's a README that captures the next steps of sort of, that's going to be a living document to capture sort of where the project's at and where it's going. And just real quick to show, if you want to jump in and just get your hands dirty real quick, this is chat.fullstack.cache. It's an end-to-end encrypted instant messaging system on its surface, but it's actually a developer tool. And so I'm in here and I created a wallet and I went to the status tab. I have other videos on YouTube about this, but basically I'm synced up, and here's the pay to write demo right here. And the documentation is currently living at pay-to-write-database.fullstackcache.nl, and there's a link here from the GitHub README. But this is an example of the JSON RPC over IPFS. I went to the JSON part, and I'm going to give it the read all command. So this is going to instruct the database to do a data dump and dump all the data in the database, which is not a whole lot right now. So I'm going to click on it, and I'm going to paste that JSON RPC command in there and hit enter. And there's the database responding with all of its data. And so this is just I don't want to go too deep in here. This is just to whet your appetite. But this is an example of the JSON RPC of how you could interact with this. It's just one of those interfaces that I showed, this middle one right here. So I'm going to leave it here. I'm going to do additional videos getting a little deeper into the weeds, into the architecture and the code, but hopefully this serves as a high-level overview of what is the pay-to-write database. So what are the problems it solves? Roughly, how, at a high level, how does it work?